Hi, I'm Brian Allen, Engineering Manager with Flomatic Valves. Today we're going to be discussing air vacuum valves. So why does air matter? It directly impacts efficiencies, pumping operations. Air is very simple, but can impact systems greatly. It can create water hammer conditions, again, efficiency in systems. It's not always understood in systems and often overlooked. So on a new system, those pipes are full of air. We have to exhaust that air out of the system. Water contains 2% air by volume. As the system is flowing and that water works through, that air can be pushed out. So that has to be taken out of the system. Temperature has an impact on the air volume in water. As the temperature lowers, the air volume increases. Pumps and systems, turbulent areas like elbows, T's, joints, can create turbulence in the system and impact the air that's in the water and make it come out into the water. So we have to relieve that in the high points in the system. Air pockets and high points can block flow. They make the system pumping inefficient. The pump has to work harder to get flow through the system. Having air entrapped in systems creates up to a 10 to 15% potential inefficiency, which long-term can cause issues and maintenance issues, and is also very expensive. So there's an American Waterworks standard, AWWA C512, that typically applies to air vacuum valves. There are basically three types of air valves. First being a large orifice air valve. It's air release, vacuum relief. It allows large amounts of air to exhaust from the system on startup, and on system shutdown or pipe breakage, it allows lots of air to come back into the system to release the vacuum on the system. The other type of air release valve is for air release under operation. It's what we call a small orifice air valve, very small orifice, opens up just for a split second under pressure to allow accumulated air to release from the system. Then we have a combo air valve. This takes the functions of the air vac and the mini air in one unit. Large orifice, air relief on startup, vacuum relief on shutdown, and small orifice for air exhaust under operation. So it combines all three functions in one valve. Air valves are typically installed at high points on systems, whether it's a high point on a grade going up or allowing vacuum relief on the grade going down. There are three different types of air valves. Large orifice air vac valves. This is a large orifice air vac. The way a large air vac valve works, large orifice on top, large volumes of air in the system can be expelled at pump startup. When the water comes into the valve body, it's going to float the stainless steel float to the seat and shut the valve off. When the system shuts down under operation and the pump stops, or there's a breakage in the line and a vacuum condition exists, this ball will drop and allow large amounts of air in behind the vacuum to release it. Our second type of air release valve is an air release valve. It allows small amounts of accumulated air to be released under operation. It has what we call a small orifice, much smaller than the previous air vac valve had. It only allows small amounts of air under pressure to exhaust the system. Third type of air release valve is a combination air valve. It combines the operation of an air vac valve with an air release valve, and you have all three functions in one valve. This has a different orifice system, a large orifice at top, combined with a small orifice. As the water comes up, it levers up the internals, closes off the large orifice and small orifice. As air accumulates in the system, the ball drops a little bit, allows air to bleed through the small orifice, exhausting it from the system. It gives you all three functions of both of these valves. We have clean water air valves and we have wastewater air valves. What's the difference? When we use an air valve in clean water, we don't have any particulates, we don't have any waste, there's no slurry or sludges. We have all of that when we have a sewage type valve. We don't want any of that media to get up into the workings in the orifice area and the linkages of the air release valve. To the upper end above is very similar in the way it works. We have all three styles. We have air vacuum valves, we have air release valves, and we have combo air valves and wastewater. But a quick identification of a wastewater valve versus a clean water valve is going to be the elongated body typically, or it may be built out around the bottom to create more room for sludge and grease buildup in the valve bodies. So where are air valves utilized? Wastewater systems, municipal systems, irrigation systems, any type of a system that you're pushing water through pipes, through a network, you're always going to have air either in startup or inherently in the water that has to be removed to make the system efficient, run efficiently. You typically install air valves at high points. It depends on what it is. If you have a pumping system, for instance, and you might have a deep well pump, Every time that pump starts, there's going to be air in the system that has to be expelled. Something like that would be a throttling type air valve that you can control the incoming velocity of air and water in the system so you don't create water hammer. Beyond that, you're going to have air release, air vacuum valves, so the large amounts of volumes of air in the pipeline can be pushed out on startup, and on system shutdown, vacuum can relieve the water vacuum in the system so you don't collapse pipes. It's very important. So typically at pumping installations, right after the pump and at high points in the system, combo airs are somewhat safe to put in most places, but we really have to understand your pipeline, your water velocities, your pumping conditions, your elevations, and the length of the pipe to really determine what is the best valve for each specific location. As far as sizing air release valves, we have some basic charts, but what we really want to understand is a lot of different variables on your system. We want to know the pumping velocity, the media, is it clean water, is it wastewater? Your elevations, your pump horsepower, the length of pipe that is run, you know, how long is your system? Is it 20 feet or is it 20 miles? And is it open discharge or closed discharge? We really have calculations that we can run all this data and give you a better result and get you the proper type of valve and the proper sizing for your application. Some maintenance tips on air valves. Periodic maintenance is required, particularly on the sewage side. We can have grease buildup in the bottom of the valves that has to be cleaned from time to time. These valves are equipped with backflush holes, so you can backflush that valve and push some of that grease out of there. It's kind of a typical thing for municipalities to have a couple of sets of valves. So they'll go out and pull a valve off, put a clean valve on it, and then maybe 6 months later they're going to go out and switch those valves out again so they can clean that valve and get it prepped in the shop ready for the next application. It's important to always follow the manufacturer's O&M for periodic maintenance. Air release valves should be inspected frequently, looking for clogging, for leaking seals. It's important to keep the vent holes clear. If these valves are installed outside or maybe in a pit where insects can get to them, it's important to put a bug screen on here or some type of screen so that bugs can't get into the valve and clog it up and prevent it from working properly. So advantages of air valves, they're there to prevent pipeline collapse due to vacuum. We want to reduce water hammer and surge pressure. It improves pump efficiency. When air is in the system, it's very inefficient and can have costly effects. We want to extend the system life and lower maintenance costs. Disadvantages and considerations: like any component, air valves need to be properly selected and installed. Okay, incorrect sizing can lead to inefficiency or failure. They must be accessible for maintenance, and some models may require periodic inspection, as we've already discussed. Now we're going to take a look at how air release valves operate and function in our R&D lab here at Flomatic behind me, and we can show how air release works and how air vacuum conditions can be mitigated by the air release valves. We've got a presentation of our Combo Air NXP here for you. We're going to show how the system functions without any air release valves online. We have isolation valves on our air release valves. They're currently isolated. There's no function here currently. We've got some elevation changes here for you. We got clear pipes. You can see the water run through the pipe. As the water comes in, you're going to see the air in it, making the grade here. It's going down a slope. Now we shut the pump off, and we're going to have a vacuum condition exist here. When I go to drain the valves at the low point, two positions, you're going to see the vacuum condition, okay? This is vacuum. The water can't flow through the outlet because it's pulling the vacuum from the system. And you're going to see eventually this side is going to continue to pull the vacuum from this side, and it'll pull it up and over. As you see right here, okay? That's the vacuum trying to pull that water out of here. Okay, in a big system, we can collapse pipes this way. Okay, eventually it's going to allow it to drain out, which it has now. So now we're going to run a second test with the air release valves online. Okay, I'm going to open the isolation valves on each of the 3 valves. We have our drain valves closed. We're going to start the pump up, and the valves are going to allow some air out of the system. You're going to see that water column feed through a lot cleaner. Okay, a lot less air. We got a little bit of a vacuum here, but you're going to see that pipe fill up much quicker with the air valves online, allowing the air to release, also allowing vacuum to relieve that here. We already have solid water column through the first stage, and this is building. Valves are still releasing air from the system. They're spitting a little bit. We're going to test our ComboAir NXV under flow conditions. We're going to start the system up. Air in the pipe. You're going to see the air work through the air release valve. The water will come in, and we'll get the slope filled with water pretty quickly with the air release valve, vacuum relief online. Water coming in the inlet side. It's going to happen pretty quickly. Okay, water coming in, air working its way through. Okay, we already have full water column on the other side. Vacuum relief worked. Now we have a full water pipeline here. We're going to run our 2-inch line with the ComboAir NXV isolated, so there's no air release valve on this line currently on startup. We're going to start the flow. You can see the water come in, air. We have water separation on this side, vacuum side. Slowly making its way, air bubbles making its way through. Now we have full line of water